Okay, so I would like to find the value of k that makes these three vectors dependent. Okay, so I write down a dependence relation for those three vectors. And I'm going to use the assumption that u, v, and w are independent. Okay, so I'll expand and collect like terms. And what do I get? Well, if I look at the u terms, what do I get? I get a plus kc times u. And then looking at the v terms, you get this guy and this guy. So that's 2a plus b times v. And then we get w terms right here and right here. So 3b plus c w equals 0 vector. But we are told that u, v, and w are independent. That means that these three coefficients must be 0. That gives me a plus kc, 0, 2a plus b, 0, 3b plus c, 0. Putting that into a matrix where the columns are A, B, C, meaning the variables are A, B, and C. The last column will be 0. I get 1, 0, k coming from this equation. Second equation gives me 2, 1, 0, and 0. And last equation gives me 0, 3, 1. Okay, now let's reduce this matrix and see what happens. Now, what I want is I want A, B, and C to exist such that this equation is true, and I want these A, B, and C to be not all 0. So I'll keep that in mind as I'm reducing here. So I'll do row 2 minus 2 row 1. Give me a 0 and a 1 and a minus 2k, 0. And still 0, 3, 1 on the bottom. Now, what's the last thing? On the bottom row, what do I want to do? I want to eliminate that 3. So I do row 3 minus 3 row 2. Okay, still a 0 on the bottom right. I get a 0 there. That looks like 1 plus 6k. And I'll copy in the rest of the matrix. Et voila. Okay, so what do I want? My columns are the variables A, B, C. I want A, B, C to be not all 0. So I want this system here to have a non-trivial solution. Now, that means I want a 0 right there, because having a 0 right here will give me a non-pivot column, which will give me a free variable, and will mean that there is a non-trivial solution for ABC, which is what I want. So k is negative 1 over 6. That will ensure that I have a non-trivial solution for A, B, and C, which will yield going back up here, which will yield going back up here. It'll give me a dependence relation as required.